So guys, this is last week class. And last week actually just we can say is introduction to Z notation. Okay, Z notation, and there we take a very simple example just to know how it's the structure of the specification in Z notation. So just to remember you, we have the main item in Z notation is the schema. Okay, so we have the schema, and the schema is two parts. The first part is the declaration, and the second is the products. We have two types of schema, at least two types. We can say is the state schema, which is which represent the structure of the system, and the second one is the operation, which represent the dynamic operation or the dynamic aspect of the system. We take small example, which is the counter, and we see how we write the specification for this example. So guys, this is last week. So here it was the complete specification using Z notation. So we start writing the specification. We start with Z notation. We start with the counter as the state schema. In the state schema here, it's the structure. What's variable that we use in this specification. And then we go to initial state to reset any variable of these variables. And the second thing, or the third one, is the operation. Here we write three operations. First is the increment, decrement, and display. So this is, as you see here, is a very simple example. So today we'll go one more step, which a more complicated system. It's related to database. We have to create a database. So this is the second second lecture in this in Z notation. So today we'll start with example of different than our previous example. So today,
Sir,
yes,
sir. Record, sir.
okay, I record. Okay, we record again. Okay. So today class, as we say, today we will go one more step further to see how we can model other types of systems. So in the last system, you see is just counter. We have only number, only one variable, and this one can be increased and decreased. That's all. So how about if we can say is more complicated system that need to save the data, system that need to that is have some relation between the data. So how we can model such system. So today we will learn how we can model that kind of system. So we will start with an example of how we can model more complicated system. In this example is BirthdayBook example. We will see. Then we will learn what the elements of Z notation that are needed to model such system, and then also the operation and the set and the operation, because we will use the set to model this system. So after we complete this example, we will go for more details how we solve other problems similar to this problem. So we'll see the element of Z notation, the operation and the set, the relation between this set, also the function and relation. So this is the example. As you see here. We have, maybe all of you know what's mean birthday book. Birthday book actually is a system that record people birthday. So we just record two data, only two data. We want to record the person itself, and the second thing, the dates. A very simple example, just we have the person name and its birthday. Person name and its birthday. So this is, if we divide our system, we say, okay, what the structure do we need for this, for modeling this system? We need to define and declare these two types, the person name and its birthday dates. Okay, this is the first one. Okay, what were the requirements of this system? So we say here the system is able to add person, the name and the birthday. So the system able to add the record. So here each record is the name and the birthday dates. The system able to find the birthday name, the birthday by name. So you give the system the name, it will show you the dates. And lastly, the system able to find name by giving dates. Okay, it's the opposite of the second one. You give the dates and then you will get, you give the name and then find the name by giving dates. So you give the date and then you will get the name. So as we say here, if we think about this one, we have to think from two sides. What the structure of this system? Why we need to find out what the structure of the system? Because based on that structure, we will create or develop the state schema. The structure is here is the state schema. And then the operation. Here we have three operations. So after that, we want to also develop the operation. So here is the operation. You can say is the operation. It's these three requirement, and the static aspect or the structure. It's these two requirements. So here, if I ask you how we can model such system, what do you think about the database? How many tables do we have in this system? We are talking about Z notation. Z notation is a little bit complicated. It's not that easy. So we are using here. We have to use the set. Okay. So let me write it in set. Okay. So in everything we have to use set. That's why our options are limited. So the set here actually it's a number of elements and we can only add and delete. So to represent this problem, which is a birthday box, we can use one table. But here actually in Z notation, we have also to find something we can say is the primary key. If you know that in each table we have to create primary key, right? So here is the same thing. So we start create the set, and we will have, as your friend say, one table. Then maybe we can say is the name of this guy, and this guy is related to, this name is related to dates. So name, or we can say n only, name and dates, and then name 2 and dates 2, name 3 and date 3. So we write it like this. So it's okay, this is one table. So but here we have problem that's okay, maybe we can have, for example, the same. Here we have name 1 and date 2. We can have the same name 1 and date 2. So we have to control this one to be only one name, only one. We don't repeat this name. So let's see how we can develop the structure of the system. Actually, we can do like this. Okay, maybe if we consider only this birthday, the second set, you see, we have to write, or we have to use the set. So this is set. See, if we look to the second one, we have the name and the birthday, name and the birthday, name and so this is enough. But here we have problem that we cannot control. Maybe it will come the same name many times or the same record many times. So we just also need to create another set, and this set it's we can say it's unique. All the item in this set is unique. Okay, we don't have to repeat any item in this. For example, cannot find Johan the same name, exactly the same name twice. So this is the structure of our system. We need to build this, or we need to write the specification of this system. So what? Okay, this is some information. Okay, how the one I just explained. This explanation will allow you to do three things. Store the information about the person name. Okay, we store it here. Okay, add person, find person by name, find. Okay, so here we have the set noun. It's each one is corresponding to one item here. Okay, and this set will not be repeated. So here we want now using Z notation just to write the specification for this system, and then also the system should able to add find by name and find by birthday. So okay guys, I will explain and then later you help me. So here we have first, as I told you, we need to because okay, we have integer, right? Integer, which is the integer numbers. We have z, which is the okay, this is, we can say, is predefined data types, but we don't have name, we don't have also date. So this one we have to define. See guys, define, not declare. Here the first step, we have to declare or define these data types. So just the definition is like this. The one is I circle it here. This is the definition. Okay, so just two brackets, and then you write, for example, if you want to only declare the name, okay, you just write name. You want to declare person, you just write person. You want to declare date, so you want to declare both, you just write two together. So we declare first the data types that we need. We need only here the name and the dates. So the second one, now we want set of. So the noun here, it's set of names. As you see in this example, the nouns also is set of names. We have here the birthday. We define the birthday as, you see, is the same structure. You see here we have this name and then arrow and then dates. So the same structure of this. That's mean each name of this set corresponding to date. Each name corresponding to one date. Okay, for this point. So here, okay, that's why we say, okay, after that you will see now what we need. We need to create set. So in the next slides, after we finish this example, we will learn the set and something about the set, and then something about the relation, and then also you see, you know something, the domain and the ring. So here also we need to find what's mean the ring and the domain. So later, this is also our today class. So the third line here in the predict, which is the invariance, because here the state, here is the state schema. We have the unknown, we say is the same. This one, the norm, is the domain of birthday. So as you know, we have, for example, if we represent this relation as what we can say is mapping diagram. This is mapping diagram. So we have, for example, name 1, name 2, name 3. Okay, and then okay, it's related to birthday. You can see just day 1, day 2, and day 3. So domain, this is the domain, and this is the ring. Sorry guys, as I told you, the writing is not nuts, but okay. So here, what we want to say here, that means this relation, only the domain is the noun. The domain only from the noun. Okay, so we have, for example, okay, it will be like this, for example. So the domain only from the noun, doesn't come in from any other else. That means we try to strict, okay, we only want this, the set of the relation, this relation, all the domain is coming from noun only. So this is the data, or we can say the state schema. This is the state schema. This is the state schema. So we finish now the state schema. So just here maybe more about this one. So now here, if you see here, sometime if we add any restriction, for example, we want to just, you have only limited number of record, for example here it's open, you can save as much as you want. So we want, for example, add something, we can add it here. So anything is related to what we can say limitation or restrict, we can add it in this place. So here, as we say, there is no number, there is no limited on the number of the birthday records, no restriction about the format of the name and the dates. Just okay, just if you see here, names, date, okay, how it's look like, this is doesn't care. And then here, how many birthday can person have? This is some question. This is a question. How many birthday? Maybe we have to say it's only one. The person have only one, because we use also the relation. Later we see the tab of the relation, and each relation on the main of each relation. We have many tab of the relation. We have partially, we have total, we have so many tab of relation. Okay. Does everyone have a birthday? They base also, this is based on the relation. Based on the relation. What relation do we use? Because when we writing or when we study this relation, we will see that some item can be some item in the domain can without not mapping to any items, and some kind of relation it's compulsory. You have to all the item here should be related. All the item in the domain should be related to another one, and some and other relation, all item must be linked or connected with different item in the ring. For example, we cannot find for example A and B is connected for example for this item. So it's based on the relation. So when you select the relation, you have to be carefully. So as the same thing is based on the relation, So here the data, or we can say the state schema. So what we mean by the state schema is the we can see the structure of the system. The structure of the system. And based of this, any updating for this state schema. So we have also, we can say, okay guys, one thing guys, this is state, state, that's mean now when we say okay the name here, we can okay if because we have something we call it state machine. What's mean state machine? Okay, if I say now I want, this is the state schema, but if I want the state value, I want you to give me the first state value. What's mean by state value is the state itself. State itself. This is the schema, this is the structure. But the state value, it's the value of these variables. So here, if we say the first, okay, if we consider this one the first, we add the first item. So the noun here, the item of noun, it's for example John. Johan. Okay, and the relation, the birthday, it's, you can see like this, the birthday will be June and 25 March. Okay, this is now the state. This is the state. So maybe the next one, once we add another one, we can say, okay, now is we have another one. With another one, it's milk and 20 December. This is the value. So the third one is 2020 December. So this is the value. Each one have, now we have, because if we consider the system uh, as node, as a node. So each time we add, we change the system, we should have new value or new state, new state, new state. So once we have only one item in this state in this system, so we have only this state, and then next we have another item. We add another item, so we add, and that's why some we can see later we can represent it as tree. Okay, this is the first state, and then the second state, and then the third state, something like this. So guys, don't get confused. This is the structure. This is the structure, but the items, the value, it's something like this. Is the value of the coming from the structure or coming from the real value. Real value for each item. For each item. That's why we say when we change the state, we should use delta. When we change the state, that means something like this. We add new value. We add new state. We add a new state. We change the value, that means we add new state. Okay guys, so the initial state for this schema, for this system, so if you see here we have the main items here. The main one is the noun or the birthday. Actually we can say both, but in fact actually is the noun only, because based on, if I delete Susan, and then I delete, so in the end the birthday without deleting this, which become 0, become null, empty, because as we say this is link, this is the noun, is the domain of. So if no, the domain is empty, so that means by default this relation is empty. So we have only this noun become empty. It's not wrong if you also empty the other one, the other birthday. So the second one, now okay, this is the initial state. Just we empty or we save null to none. So we have now adding operation or adding items. So guys, you see now, later we will see how we can, more about adding. Now just one symbol, how to add, that's all. So we want to add items. That means we have a relation. Now we have the name and the date. So to add, for example, as we say, we have there, it's okay, any name, June, okay, let's use the same, and 25th March. So we want to add these two items. So we go to the relation, and then we add it. Okay, so how we add it? You see guys, we are using set. So how to add to set? You have set, the set, and then just I want to add one item. How I add one item? You remember how to add? So any answer from you? How we can add one item to the set? You already know the set theory. Okay, we have used union. Okay, that's all. You see, just that's why we say it's easy to understand. For Z notation, it's easy. Just you say, okay, we want to add. Everybody maybe know how to add to the set. So we just add new item to the set. So here, how to add. Okay, first of all, you see here, as we say, this item should not be added before. That's why we start here with, okay, let's come here first to these two lines. Name, this is the new name. Okay, no problem. Let's start from the beginning. First here, we write here the birthday book. The birthday book is the state schema. So we mention the birthday book with delta. That means we want to change this state. We want to add new value. Okay, we have here the name and the date. So just we have new variable, the variable is name, and question mark. That means this variable is input. We have input here. Okay, question mark, that means it's input. And the date also it's input. So we have now two variables. So this is the one we want to add. So we will add the relation. Add the name. Also we have the relation between this and the date is small letter, because the capital letters, that means the data types. The capital letters here, the data types. So this one is the, you can say, the new record. We want to add this record. So first here we add a precondition, and this precondition said if this item is already added to the known, so don't add it, because if this one not satisfy, this condition not satisfy, this will not be implemented. So the second one, now we add to the birthday. We have birthday. As you know, this is the prime, that means the new value. This is the old value, that means we have the record. Even okay, before now, since it's the first time, so it will be empty, right? That means the empty plus this record plus this name related to dates. So now we'll add the first item. So this is how to add. How to add? We just use this operation, which is union, to add to the existing value. We have another operation also to add. We have another operation. It's same. If you just Google it using the mathematics, because it's in math. Okay, how to add item? Not, don't mention the notation. Item using in the set theory. Add item in set theory. That means how to add one item to the set. They will give you list of one of them. It's union. Okay, this is one only one. So there is another one we have. We say it's overriding. I think overriding. This is also can add new item. Okay, guys, this is for adding new item. Adding new item. Is it clear? Hello, guys.
Yes, clear.
Clear, Alhamdulillah. Okay, okay, we have to back now. So for this is just these two item or these two operation. We already talked about it. This is the delta. What's mean the delta? Because as we say, we have now state. We have state schema. Anytime you edit or you change this state, we have the state is the birthday book. Anytime you change it, you have to use delta. No change, we just display the data of this. So you use this notation, which is z. Okay, z. So here we use, I just add this one to just show you okay how we, I mean the item, because here we have birthday. Even you change only one variables, so you have to use this delta. Here we change the birthday, even only the noun. We check just to check, but we change the data or the birthday, so we have to use delta. If there is no change, you don't add any items or you don't change any items, so I just use z. Okay, now we come to this, the second notation, which is z. So anytime you use prime, that means you change the state schema, you change the state, so you have to use this notation. So now for the second operation, finding birthday. How to find the birthday? That means you have the birthday. No, you have the name. You have the name, and you want to find the birthday. So as you see here, we have ours is just of a relation between the name and the date. Okay, so keep in your mind, anytime you want, because now, okay, this is the birthday. You can consider this, okay, this is, you can, not only for this example, for any example, you can consider this something like function. And anytime you have name and they want the birthday, you just write, for example, like this. If, okay, let's use the same, no need to use if. For example, birthday, this is the function of birthday. You have the name, you just write the name. Okay, and this one will return what? The date. And the same thing, if you have the date, birthday, the date, it will return the name. So this is how to find. This is how to find in the set. So we have the same thing now. We have the name here as an input, and the dates here, if you see here, we use the second notation, which is exclamation. So exclamation, anytime you see, that's when there is output. So first we have to check if this item is member of known or not. So this is the precondition to check. If okay, just go to the second operation or the second sentence. So the second sentence, just we give the name and then the dates will we can say it will be the output. Okay, give the name and then return the date. So it's super easy, huh? So we just use the state here. We have to use it, the state schema, and then the name input and then output. And the second thing, precondition, after that we send the birthday, we send the name to the birthday, something like, as I said, like a function. You send the name and then you will get the date. So here, remind. Okay guys, here we have the, what we have here, we have the date. So why we have the date? Okay, let me explain first. We have the date and we want, okay, this is the birthday, our function birthday. So we have the date, so we have to get the name. Okay, so easy, similar to the previous example. We should be like this. We have the name, we get the dates. So what the problem if we have the date to get the name? Why not? Okay guys, as you see here guys, in our example we see the dates or the name, it's unique. The name is unique, so we are sure that only one item will back. Okay, because we have only, for example, for this name, not only John, not only Susan, no, maybe it should be like primary K. That's why we say every time we check this item. So the dates or the name, it's primary K, something like primary K. So we are sure that's only one item will back. So in that example, if we say the birthday date, it's only one item will return, which is the date. Only one item. So we use this function. We use the easy one. If you also in your example is the same issue, there is no repetition in your items. That means each item is corresponding to one item in the another side. So you can use this function similar to this function. But here, what the problem? The problem here actually, guys. Okay, for example, today it's 9 of March. So many people, they have the same birthday. They have their birthday is 9 of March, right? So in this, you can say we don't have only one name. We don't have only one name. We'll have set of name. Maybe we have name number 1, name 2, name 3, and so will be set, not one item. That's why we need to find another way. So guys, this one actually also now a new thing we will learn for more details about it, how we can write this sentence. So this is actually we can say is comprehension set. So in this set, if you see here, we have card. The card it's retained, or we can say is a set. Is a set, and this set or this set, the item of this set is only noun. It's any subset of noun, any subset of noun. Okay, that's mean set of names. This card is set of names. Here we have a condition. The condition. What the condition? Okay, now we use the same function here. If you see here, the same one. The days, which is today dates, today, equal to birthday, and something like we will have loop, and this loop it's n. Okay, so this n is all the member of noun, all the member of noun, this one. So we will go through this set one by one. Any birthday is equal to today dates, so will be saved in this card. So maybe before you know something about this, so this is another way to express the or represent the set. So we have here, this is, we can say, the declaration part, and this is the expression part or the constraint. So it's all non-function, any item from non, but its birthday is today. Any item, but its birthday is today. So this one will save to the card. So this is the how to find many items. If you are sure that's only one item, you can use the simple one, which is like this. If many items, so we have to use set. So this is the remind. So here also, okay guys, we finish with this example now. We finish with the example. So how to write this example? You just write now, okay, the state schema, which is look like this. We have to declare the items. We have name and the relation between the name and the dates. Then we write the initial state. We add, how to add, and here how to find the birthday. No, this is how to add same. Here how to find the birthday date, and here how to find the names of people they have their birthday is today. So the different here and there, this is only the output is only one items or one value, but here the output will be many value. So we save this value to set. So that's why here cards it's declared as a set of. So this one, if you see here, we use it because it's set, and also in the state schema, right here we use it because here we say this is set. Later we say this is, we call it power set. So guys, this is okay. This is our this is the birthday book. There is another way to declare. You see here, you can declare all the state schema, or not the state schema, the schema in general, even state schema or operation schema in one sentence, so in one line. So this is how we can declare. So guys, now we have a question for you. You have to answer this question. Okay guys, so guys, how to delete one record? You see how we add one item. So how we delete one record now? We just use union. Okay, we can say is the relation, the old relation, the new relation with prime, the old relation, and then union, the new record or the new item. The item here, it was the name related to date, name and date. So if I want to delete this, how I can delete it? Difference, okay, we just replace this one by this difference. So that's why we need to know more. We need to know more about the set and the operation on the set. How to delete, how to add, how. So we need to know more about that. That's why the next slides is just all about it. So another question, how to find the total number of people. Now we have two sets. The first one is known. The second one it's birthday. Birthday. So once you add here, it will be add here and the reverse. So where how to find the total number? I mean now we have a number of people here, number of people and the birthday and their birthday here. So how we know how many people already saved in this system? So this is same things. We have to know more about the set. Now, okay, it's easy. You have the set, three items. For example, I just want to return the three items. They want to this any function return three. So how? Okay, that's why we need to know more about the set. So we just write hash. Hash. Okay, the third question. How to modify the system to be able to add place of birthday. Okay, we have now the date. We have the date. How to add the place of birthday. So you have to find how to add the place of birthday. How? Maybe we just say, okay, the name, right? The name, just we say n, okay, name. And then we have the date. We can add another relation. Is it the place of birthday? Can, can, can do like this. Or we can say, okay, now we have a relation between the name and the date, right? This one, name and date. So we have another, we add another relation, which is name and place. So many options.